So now that we've talked about synchrony and asynchrony, let's start turning our attention to how Java supports asynchrony, assuming that we want to be doing asynchrony. And we'll see that the first step in this journey is to cover Java futures, which have been around for a long time. And we're going to do this for a couple of reasons, but at the very least, we want you to understand that they provide a foundation for the Java completable futures framework, which came later in the history of Java. And we'll also talk about a fun human-known use of Java futures that will make it real easy to remember what they do and how they work and the pros and cons of them. So let's start off with that first. So a future is essentially a proxy that represents the results of an asynchronous call. So the concept of a proxy was introduced in the Gang 4 book, in the Pattern-Oriented Software Architecture Volume 1 series. There's a proxy pattern there. It's basically a stand-in for something, if you will. And the way things work is you invoke an operation, say synchronous, that goes off and runs, and you get back a future, and the result will be obtained only after that asynchronous computation completes. Some good examples of this from everyday life are table tent numbers or table stands. You've probably all used these things if you go to delis or various kinds of restaurants. If you go to McAllister's Deli or Jason's Deli, you'll go and do the following thing. So you place an order and you get one of these table stands, table number stands, or table tent numbers. So let's talk about this in the context of well-known fast food restaurants. And this is a little bit of a history tour through the history of fast food and differentiating products, but we're going to look at McDonald's and Wendy's. So these will be our two examples of human-known uses of this. So historically, McDonald's would pre-cook a bunch of food, like Big Macs and French fries and little cups full of soda and so on, and they would cache that pre-created food content. So you would have something like this, where you'd have some French fries and a heat lamp, which would stay warm. And when you went to order, you would come up to the cash register and you'd say, I want a Big Mac with fries and a Diet Coke or whatever. And the person would synchronously interact with you and take your money, turn around, grab the hamburger, grab the French fries, grab the drink, and boom, that was a synchronous transaction. That was the classic way of doing things. At some point, someone came along and said, hey, we're gonna be better than McDonald's, probably not much more healthy, but we're gonna be better than McDonald's because we're gonna cook your food to order, and in that case, rather than waiting synchronously for your order to be served from the cache of pre-cooked hamburgers and French fries, what they would do is you would place your order and they would give you like a table tent number or table stand or just a receipt with a number on it. And then you would go off and do something else, like surf the internet or read a newspaper back when we read newspapers, or talk to your friends, whatever you would do. And then when your food is ready, it would be redeemable somehow. We'll talk about how that could be redeemed. So what you would get back would be a future. So that's a quick overview of the way in which we can map these concepts to everyday activities. And of course, the pros and cons there were that the McDonald's transactions were sometimes faster, because things were pre-cooked, but you weren't getting as fresh results. Whereas the Wendy's model was a little bit more complicated, but you would get better results, and you would also get a chance to do other stuff while you're waiting for your food to be cooked to order. Okay, so that's the end of the overview of Java futures. So now that we've talked a bit about the human-known use of futures, let's go into more technical details and talk about the methods that are defined in the Java future interface. So futures were added to Java in Java 5, which came out in the 2004 timeframe. It's hard to believe that was 20 years ago. And that was something that came here. If you look at the Java timeline, this goes up to 2019. There's been a bunch of other versions of stuff since that point, but this is when things came out for Java futures. A future is a proxy that represents the results of an asynchronous computation. And there's a bunch of methods that are provided to do things on a future, like, is the future complete? You can check. You can wait for its completion. You can retrieve the result. You can cancel it, and so on and so forth. The way this typically works is you start by submitting a task to run asynchronously, and the task will give you back a future in return. So here's a simple example. where you have a program that submits a task. We'll talk more about what a task is. A task is typically a runnable or a callable. We've talked about these things before. And you submit it, you get back a future, and then it'll process in the background in some thread in a pool of threads. Once you get back the future, you can do various things with it if you are the caller. You can see if it's done. You can say, is the future done? That's one thing you can do. You can check to see if the future's been canceled, and if it's not been canceled and you're tired of waiting, you can cancel it. You can also use it to retrieve the results of two-way operations. You can say, hey, I'm going to block for an indefinite period of time until either it succeeds or fails, and I want the result to come back, please. And there's also some other things you can do. I should point out that you can also block in a timed way. We'll talk about that later. This capability provides the basis or the foundation for Java's CompletableFuture class, which is really where we're headed with our discussion. So you can see that CompletableFuture implements the future interface. So all the methods defined in future are also available in CompletableFuture, plus a boatload of more stuff, like 60 some other methods are defined there that you can do all kinds of stuff with. So CompletableFuture provides lots more capabilities, and the reason for that, of course, is because out of the box, futures don't really give you what you want in order to be able to do effective asynchronous and/or reactive programming. So that's the end of the overview of the second part of an intro to Java futures.